Right, the counter is still going up of participants, but nevertheless, let's get started. So first of all, massive congratulations to you as people, to you, to us as an organization. The amount of colleagues that signed up for this course was really beyond expectations, and certainly we have heard you, and we have heard there is a very strong demand to learn more about AI, to learn more about how this can change your workday. And we really want to build an entire community around this. That also means if you or a colleague is interested in conducting workshops, and that can even go beyond AI, it can be on all the 4 key topics we have, which are aligned to the 4 tests that you need to pass as part of the first level bootcamp of the new ways of working. If you're interested in organizing a workshop yourself, you can reach out to me, you can reach out to Andy Chun, and we'd be happy to help you, to give you resources, and also to propagate, of course, that there's something great to be learned. It's an amazing opportunity. And let me say again, big thanks to everyone also for the great interest that is reflected in all these signups. With that being said, let's go right into the workshop, and let's have a look at, so we still have a little bit of background noise. If you could try to go on mute, that would be really great. Thanks. First of all, let's have a look at what you'll be able to do once you're at the end of these. I think it's going to be 100 minutes we set for it. So this is really what at the end of the morning hour you should be able to achieve. So you can see the AI is tracking now in real time on my face. I'm intentionally moving around a little bit here. But what it's doing is it can really here track the outside of my face. It can track my eyebrows, the eyes, the nose, and also the mouth. And the thing you're going to realize is it's actually not that hard to do these really, really cool things. And a big reason for that is that Python is open source. And then the hardest challenge in this kind of boils down to being able to handle images as data. And they are surprisingly similar to Excel spreadsheets, which is handy. And the second part that's important here is on how to handle these data and put them onto that image. But that application will focus a bit more on it in the second part of the course. This is a very 2-tiered course. And essentially, we want to focus on helping you achieving your new workday. How does the new workday look like? Ideally, you come to the office and there's no more things that are really repetitive. You know, when you have an Excel spreadsheet and you have to go through and copy and paste a lot of things, and maybe every week you have to do the same tasks. That should go away, and we want to help you in achieving that. There's less need for documentation in your new workday because the structure that a programming language as such imposes onto the way you work is the documentation in itself. And of course, many of the things that you currently have that kind of distract you from achieving what you want, they can get automated away by you yourself, and you get brand new superpowers that you didn't even know about until today. This is part of the wider AI first mindset. So 2021 is really the year of AI and data in the Pru. And we also have the AI Bootcamp, which is a 5-level journey. We're going to focus on the first level with today's initiative, and also with the AI Learning Accelerator. The first level in your journey, of course, is passing all the 4 intermediate tests. They're quite challenging, of course. Pass all 4 of them. And we're certain that with the AI Learning Accelerator and also many of the things you're learning today, you will see greatly improved scores. You have seen in the town hall, it's really open for all. If you're in digital or not, you can become an AI expert. You can become a coding expert with the materials and the support that we're giving you. Now let's think a bit more about Python. And obviously Python is a programming language, which means it's going to be text-based. Why would you ever go into an interface that's not as nice looking as maybe Excel or some other nice UI software? Well, essentially, the flexibility that Python gives is the key reason. And some of them you certainly have known about because you have signed up for the course. And obviously, we have advertised big that you can do all sorts of Excel jobs. In fact, you can do, by definition, everything you can do in Excel, but you can then also automate it. You can do more. But at the same time, some of you are already working with databases, and there you're working with SQL. And what then happens is oftentimes you do something in SQL, and then you have to download a file and do something in Excel, and you have to do all of it by hand, and you've got 2 different things standing right next to each other, but it's hard to make them talk. In Python, you've got everything in one. On top of that, you also have pieces like you can do AI, you can work with very different data. We just saw I was using a video input that will work a bit more on and images in the second part. We've got big data, and that is getting more and more into day-to-day work actually. And you can do really cool stuff. You can even build your own websites and host them on Python. You can share your applications. And that's really something where everything gets a lot more professional, right? If you ever thought about, okay, how do I share now an Excel spreadsheet work output with the customer? It's really, really hard to do that. Whereas here, you can really have a professional way of sharing it and integrating with other teams. And really the flexibility, this house here is actually much bigger. I'm just listing down the 9 key areas which I think have the biggest impact on your workday based on the feedback we have gotten from actual Pro colleagues on the ground. In the first half of the session today, we'll look a bit more at data handling, and we'll do that with a focus on trying to do what you can do in Excel. That has been identified as a key area where we can make a big difference to everyone's workdays. And it also has the advantage that from a didactical side, it's easier to understand the concepts and also transmit the context to you. So we're going to look at how to do Excel in a code-based version, and also crucially why you should potentially do that. So at the end of this first session, we'll look at the 3 key reasons or 4 situations where you should really do it with code and how that's going to impact your workday. We'll look at data merging, and for some of you that have already worked with SQL, that also will be very useful for you. We'll look a bit of how can we do SQL together with the operations in Excel in one integrated framework. And then also you can automate everything, which is the crucial piece here, right? That's really what has the biggest impact on the workday, is when suddenly we're able to remove tasks entirely from our calendar because they can get automated away. And really the flexibility of linking up with all sorts of data sources makes it even more powerful. There is a framework in Python. So essentially Python is, as we saw, is like a house, and inside that house there are different rooms. And these rooms might be some libraries, right? So a library is an absolutely wonderful thing. A library in a programming language is essentially work that someone else has done, and they wrapped it in a nice package so you can download that package and extend your programming language by installing it. And there's so many libraries, it is literally tens of thousands of libraries, and they all do amazing things. And they all essentially are built by the world's leading experts in that field. And that makes it really powerful. And they tend to be extremely high quality. So what libraries do is really they give you superpowers, just like in the Matrix movie, where Neo goes in and he downloads and suddenly he can do Kung Fu. You can do the same thing with the libraries in a programming language, where within literally a few minutes, you suddenly gain new powers that you did not have before. And you're doing it at the world-class quality because the best experts have provided that code to you. There is a very good documentation for Pandas. So Pandas is essentially the Excel syntax for Python, and it's a very, very popular library. So even if you go through the entire course today, go and have a look at this documentation. It's well worth it. Also, if you happen to come from some slightly technical backgrounds and some of the things here are something you have already had some sort of exposure with, there are accelerated learning journeys for you. We'll cover all the basics today, so don't worry. But if you want to get a bit more into this and really make it a day-to-day part of your life, of your work, and use all the advantages to the maximum, it's a good idea, for example, if you're working a lot with SQL queries today, to have a look at this specific journey that's really tailored for people like you, or if you're coming from an R background. Pandas is really, really similar to R essentially, or other technologies in that space. So let's first look at some things where we might struggle in Excel, and I'm choosing some data visualizations here because it's easiest to understand, and we can see why these things might be challenging. So let's look at first this image here in the middle. This was produced with a plotting library in Python. We'll not do too much plotting today, but let me say this is just the peak of the iceberg. You can also do interactive plots that have buttons or other elements, or even here we have a plot with some bubbles inside. There are some plots where you can drag and drop these and they have gravity effect and everything. So you can do all the way, but let's stick to something that looks a bit like Excel. So these nice two-dimensional graphs here. And here in the middle, we already see this is a demographic chart. And that's a very, very specialized chart. So I don't think there is a template for just even doing one of these. And what happened here is we have several dimensions in the chart. So I would really, really struggle trying to produce something like this in Excel at all. Next one here, this bubble chart. The bubble chart was quite a challenge in Excel. They've introduced now a button to do it finally, which is great. But still, even though this looks really easy, it would be very hard to do in Excel because look at the color. The color of the dots is dynamic and it's dependent on some of the other variables here. So the color is a dimension in itself where we can show more information. That I don't think is possible in Excel easily. And then you start doing crazy stuff like coloring every single point on this plot, and you can't do then any legends anymore on the chart and things like that. Here, it's 1 or maybe 2 lines of code. I'm pretty sure of that. And when you want to redo it with new data, it takes you 2 seconds maximum. Another one here. So this is very interesting. The chart in the middle is something pretty straightforward, and the charts down here as well. But these are rotated and interlinked together. So again, pretty tricky to do that in Excel. That would be a combination of Excel and PowerPoint magic a little bit. And then you can't have a dynamic element where all of these are interacting together. So again, something that's tricky. This one here, Looks straightforward. We have two colors. Okay, let's abstract from that for now. The tricky part here is these colored bands, they actually show some sort of prediction uncertainty. And unless there is a formula to calculate the colored band, so if that comes from a model, AI model, of course you can't do it in Excel because there's no proper AI. It stops at some sort of polynomial regression at max. So that's really advanced here actually, even though it looks simple. And then here another example of a specialty chart that would be hard to do. So this is a Corollogram, which shows, this is not the original data, but these are correlation of the variables amongst each other. Very, very handy to understand data quickly, very hard to replicate in Excel. So imagine how much copy and paste of strange looking formulas you had to do here in Excel. One line of code again in Python. So these are very visual examples of why some things are hard in Excel. And of course, there's also experiences that are attached to challenges that we sometimes struggle with. And everyone has been there. I'm no exception, right? We've all been in this situation, every single one on this slide here. So this one, I've seen this in the head office in London. They literally every year they knew there's going to be this giant crunch, and they even ordered a buffet because they knew there's no way that people will not be in the office until 3 a.m. And that's essentially the situation where you send something off to the senior management and it's perfect work, but then suddenly someone wants to see the quarterly numbers instead of the yearly numbers that was done before. So now the entire team needs to scramble and try and redo the entire analysis. In Python, the good thing is because the code forces you to be much more structured and it's much more replicable, these situations tend to be less of a crunch time. It is a bit more of an initial investment to set it up once, but you get rid of the peak load for that, which I found very valuable in any team I have supported on learning this. We already looked at unusual things like unusual plots that Excel does not support out of the box. Excel is really, really good for the things that are properly supported. Don't get me wrong, you should still use it for many things. But sometimes when there's a specialty application or a lot of replication, that's really tough. Maybe you also have a file that's so big that Excel completely crashes. That's pretty much worst case scenario. Sometimes that can mean hours of lost work if it didn't happen to save in between. And there's some things we can't do at all, like create an AI or build an API, put something into a customer's hand is maybe the most important one, right? How do we interact with other stakeholders? Internally, you can still send around Excel spreadsheets, that's acceptable, or you can put it into an agent's hand at max, but it's very hard to go straight into the customer's hand with an Excel spreadsheet. There are some exceptions from this rule if we're working in a very industrial setting where all the customers are large companies or something like that. But for mass market, we typically want to have other channels like websites and then these. So the other extreme, and that also happens if people get so proud, they've mastered a new programming language, they've mastered Python, and now they want to do everything in code because it looks cooler. And the thing that we then forget is actually Excel is also very powerful, right? Even though it has its shortcomings, there are many situations where we should still continue to use Excel, especially if something is just a one-off analysis. Maybe it's just something for you yourself to understand some data or something where you're very sure you won't do that again. It's fine to do in Excel, especially if it exists pre-built. Some initial exploration of data, quick plots or calculations that you just have to do once and you know you don't have to do it next week or next month. Don't be ashamed to use Excel. And also when there's no need to redo or document things very much. So again, that's most likely the case. You're just doing for something so that you yourself can understand it. That's really the golden zone of Excel, and we should not shy away. The target of this course is to make you faster and to reduce the workload inside your workday. And that also requires Excel to be part of it. So don't try and eliminate it totally, but try and cut it out completely in the cases where you are starting with programming languages. Because when you cut it out completely out of certain jobs, they vanish out of your calendar 100%. That's the best case scenario. So if we try and replicate Excel in a coding language, let's think a bit first about what are the things that we very often do in Excel. Well, the most often done thing possibly is I select a field or a range of data. So I go in and I say, okay, here, this column, I take it and then I do something with it. Maybe I'm saying, okay, the sum of these fields here. So I've done a selection and I've also done some sort of formula. So here I've got a function that I was applying, in this case, the sum function. And also another thing we often do is put data together. And that's already starting to get messy in Excel, even though it's a core proposition that Excel is bringing to the table. If we want to do a data merge, there are things like VLOOKUP and other functions. But it always gets a little bit messy, and then when we do bigger merge, the pivot table is the maximum you kind of can get. So oftentimes then people revert to SQL, which is a great choice. But if we can do everything together in one framework, it has a bit more cohesion. And then of course we do some charting. We'll not do that much work on the charts today. We'll do a bit work on images in the later part of the section. But this is such a big topic that we might be organizing a special workshop just on data visualizations. Now, first of all, before we can do anything with the data, we first need to get it into the system we're working with. In Excel, it's pretty straightforward. We just click on the file and it will open by default in Excel. But Excel is a bit limited in the kind of data that it can work with. And Python is extremely versatile here. I think that might be the framework that is the most versatile in terms of data you can ingest that's available. So of course it does all the standard Excel stuff like CSV and XLS. It does also Parquet, and that you're unlikely to notice. What it is a big data format. So this is a distributed data format. You can do terabytes of data here, and you can work on it in Excel, in Python, sorry. You can also read HTML, you can work on HTML, you can even host websites inside Python and change them with Python. So that's starting to get pretty cool here now. So all sorts of formats, and you can link directly into databases as well. Again, very, very handy. So you can do a lot of database automation. You can even put AI on your database. Think about how cool that's going to be. So you read that, you do something on it inside Python, and then you can also write it again into all of these systems that you were able to read from. So you can put it straight back into that SQL database, right? That's possibility for 100% process automation here, and in a very robust manner. Now for data in Pandas. So essentially there's two main kinds of data types that we're using. One is a data frame, and a data frame is just like a table in Excel, right? And this is an example data that we're going to use throughout the first part of the course. So we've got some numbers in the first two columns here, and we also have some text data. This is another advantage. Python is very strong at working with text. This is very basic text, but of course this could be a Shakespeare novel here or whatever in every single column. And then the second type of data, so we just had the data, the data frame is the entire table. And the second type of data is a data series, and that's just one column or one row of your data. So that's a kind of linear data format. There's one more important thing, and these are functions. So we were doing that here in Excel already. We're saying, okay, give me the sum of this selection here. Now the challenge in Excel, unless you're using a code language that's integrated like Visual Basic, is it's very hard to define your own function. So maybe I want to have a function that is not part of what pops up here when I do equal and I write something, right? So maybe I want to have function ASDGG, and it just doesn't exist. What do I do now? Well, now it's getting time for some crazy copy and paste action typically. That's a bit different in Python, because in Python you can define your own functions. There are a lot of pre-built functions, and you can also use the open source through the libraries and Git repos, and simply by Googling. Don't be ashamed of Googling. It's a great technology actually for coding. But then if you really can't find something, just build your own function, right? So maybe I build my own version of the sum function, and maybe it just does the sum of everything times 2 or something like that, right, in one function. So for that, we have the keyword def, and then you can name your function here. So this example, we're naming it my function, and it has an input. So it's the same like here when we're doing sum, and the sum has an input. It says number 1, 2, 3, right? So I can define what I'm getting there. And then we can do something with that input, and importantly, return something again. In the beginning, you're very likely to just use the return to have interaction of your function with the code. So don't forget that. If you don't have the return, it just does the calculation. The return actually gives you back the result. Let's look at a bit of these things that we just heard of in praxis, in the code. So first of all, we're going to import the Pandas library, and I'm using here the PyCharm code editor. You can use any other code editor if you like any other one more. The reason why we like PyCharm is it's a bit easier for the library installations, especially in Windows. So I'm going to import that library, and within less than a second, I've got a lot of new capabilities loaded into my Python already. So this just became a lot more powerful. Now we're going to read the example data. So I've got the file here in my local folder. Where is it? Example data.csv is the name of the file. So here it is. It's in my local folder. We can also see it here. Example data.csv. Yes, it's in the local folder. Having the path like this is a good idea. Or you can also have it in a folder. So maybe the folder is named like this, right? So that's also possible. You can also give it the entire path. So if you're based on Windows, that might be something like this. Depending on where this folder is sitting. The last method, we would recommend that a little bit less, because think about what happens if you copy the entire folder. If the path is like this to your file, or maybe as a folder inside this folder and then your file, then it will copy the file and the path will still be valid, right? So it has advantages to have a so-called relative file path here. Now for a very, very important function, especially in the beginning, and that's the help function. What help does is it gives you the documentation for every object, and an object can be, in this case, a function or variable, which we will learn about very soon. So in this case, it's a very lengthy documentation here, and if we scroll all the way to the top, we can see, okay, this is the function I was trying to get more help on. It tells us, okay, the file path is the first input. And then later on, it has all sorts of information about, okay, what's the file path? And of course, the name is a little bit confusing. So it's good to have that slight help here. Also, an easy way is just Google it. If you don't understand completely something, just Google it. Documentation tends to be really good on these things, surprisingly good. So that's literally a helpful function here, no pun intended. Now, the challenge we have is if I do it like this, the data gets put here into this console. but it just gets printed out. Now, if I want to do something else with it, I actually have to store it somewhere so I can use it later again. And that I can do with a variable declaration. For that, I'm using this equal sign. And this you can name anything you want. I've named this object data. So data is a variable, and I can put anything inside with this equal. Let's do that. And now data simply holds the output of whatever was here. We know there was the read of the CSV file. So let's use the print. It's going to put it back here into the console. Alternatively, you can also just execute data itself. And we see, okay, that's exactly the CSV file that we have read. That's just the same thing like we have here in Excel. We can also use the type function, which is quite helpful because sometimes you don't know, is it the right data type that I'm used working with? And most of these data types or types in general, you can transform in between them. So there's also NumPy data format, there's also list data format. For now, you're really comfortable with all sorts of things in Pandas. So this here is a Pandas data frame. So that's really good because that's what we wanted to have and what we want to learn a bit more about right now. A data frame has very nice ways of selecting data. So inside the data frame world, the Pandas world in general, I can select things inside that data with this edgy bracket, right? So there's a round bracket on your keyboard like this. There's a curly bracket, but we're going to use the edgy one for data selections. And I can select here a column. So column 1, for example, we select like this. And of course, what we want to get is this 1, 2, 3, 4, 5. And indeed, that's the output of selecting this one column. And these parentheses here, these strokes, they're just signaling this is a text input, right? Alternatively, you can also use the double quote. That would result in the same thing. So that's just saying, okay, this here in the middle is text. Now we can also look at the type again of this one column. We said before, these one-dimensional objects, data objects, they are a series, data series. And as here, be careful, the series has a capital S. Same as for the data frame we saw before, there's also some capitalization here. So that's good. So much all up to our expectations. But what now if we wanted to select a row inside this data? I want to select this first row of data here. I would say 1, 6A. I can't use the edgy brackets because that's already using for the column selection. So we need a slight workaround for that. And that is offered by the ilog function. So ilog says, if I do a data selection after what comes here, I'm gonna actually do it for the rows. So let's do, we want to select row number 1. Let's do selection of 1. And oops, what's happened here? We've got 27B. That's not the 16A row. No, instead it is the 270. That's the second row. And the reason for that is that many times when we count something in Python, we actually start with 0. So that's a little bit unintuitive, but you get used to it pretty quickly once you use it. Essentially, all the things where you do indexation and counting, just deduct 1 from it all the time, and then you're fine in the beginning. So if we select the row number 0, that's really what we would loosely speaking refer to the row number 1. So that's a 16A. That's really the row we wanted to select. So now we can select both columns and with the ilog functions, the rows. The next thing, we can do all sorts of functions. So of course, the sum function is implemented here as well. And I can promise you one thing, everything you have in Excel is here, plus so much more. In Excel, you might have 5% of the functions you have in Python. So it's very rare to come amongst something where you don't have some sort of pre-built function that helps you a lot in getting to where you want to go. And that's really the big time saving here, that the functions are very, very powerful compared to other frameworks. We can also change the data, and obviously that's crucial. We don't want the data to stay the same all the time. We want to move forward. So let's look again at this column 1. We can take the entire column and just add 1 to it. It's going to do that to every single element. So it just added 1 to every single one of these 5 numbers that we had. And crucially, if you just do it like this, it's again not going to save it. So we need to store it into a variable. And in that case, the variable can be the column we had before. So if I'm overwriting this column, it's just going to change the original data frame that we had. Let's do that. And now we can see, yes, the column has changed. We can also look at it in the entire data frame. And indeed, everything here in the first row column has added number 1 to it. So we can do very nice and convenient changes of the data as well. Let's look at merging data, and that's really a crucial job where you will find Pandas is very, very helpful. This is also something that we test quite a bit in the AI test. So that is a skill that comes in very handy, and there's a good reason why we like it so much. We see it has a significant impact even on basic operations we do in day-to-day work. So that's something very, very powerful. Even the basics of it, even the basics are super powerful. So the concept of merging data, we also need to think about the dimensions of data. If we have a table like this, essentially this is a 2-dimensional data. We've got the columns here and we've got the rows going down. I'm labeling this as axis 1 going this way and axis 0 going that way. The inventors of this dimensionality system might be thinking about it the other way around. But it's a lot more intuitive for what we're learning today to think in this way. So axis 1 is going to be our columns, and axis 0 is going to be the rows. So if I'm saying concatenate, and concat is a really, really powerful function for merging data. Concatenate on axis 0, I just mean stuff it underneath, right? Concatenate it along this way. And if I do that, the column names are the same here. This is crucial for that looking so nicely. We'll see soon what happens if not. Then it just puts that underneath and it uses the column names to join. In this case, the column names are different because it tries to stuff underneath by using the columns. What happens is there is no column 1 here, so the value is empty. Same for column 2 and the other way around as well. So that object looks a little bit more clunky. You have to be aware of that. A nicer way of merging that might be to do it on axis 1. So let's do both examples again by concatenating on the axis 1. And that just means stuff it here to the side. Right? That's what we mean with concatenating on axis 1. And then we see, okay, if the column names are the same, then this looks a bit unintuitive. Now I have these repeated column names. So in that case, I might want to concatenate on axis 0 instead. But there are cases where you actually want that. And then for our second case, okay, this looks a lot neater than what we had before in the result. So here now, everything is nicely ordered. Mind you though, if you had a column where you actually want that to be underneath, then that would not be correct. Then the slightly clunky looking one here is rather the correct form, most likely. So we're going to look at this inside Python a bit, and we're also going to look at how to have SQL in Python. So we're going to read the exact same data again, and we're just doing that so that we have a second data that we can merge together with the data we have already read. So I can define a new variable, let's call it data2, and we're just going to read the data. It's the same thing like we had before. Now we're going to do something handy is we rename the columns, and that's a little bit strange looking. So in this case, this data variable, because it is a data frame, every data frame has an object here that's called columns. So if I look at data.columns, now I've already overwritten it with this new list of column names. But I can see here, okay, these are the column names. And then if I look at the data2 object, yes, indeed, these are the names of the columns that we have written here. Let's use the concat function. And again, these data merge functions have got excellent documentation, and there's way more than just concat, but concat itself is super powerful already. But don't hesitate and go and Google for documentation. You'll find a lot of really, really good surprises on the Pandas documentation. If we just use concat, it's going to use the default setting for everything, including the axis. So that's where it's merging on axis 0. Let's see, okay, the column names, because we changed them, they're different. So we've got this NaN means there's nothing in this field. This is just empty placeholder. Let's look and compare when we were merging two things with different columns on axis 0. Yes, this is indeed very similar to what we had here. So that is well within what we expected. We can, of course, also change these default values. So I can say, okay, use the axis number 1. So I want to stick it side by side now. And that looks a lot neater now and a lot more plausible. We can also do very similar operations with an SQL style syntax. So in this case, we're doing an inner join on column 3 and column 2C. So basically do inner join where column 3 and columns 2C have the same values. And because it's the same data frame, that's going to be the case for all of them. So in this case, we come up with the same result that we saw before. No surprise there. If you happen to have worked with some databases before, you know how powerful this is to have that together with all your other data steps, and then you can pump it back into the database. So that's indeed something very powerful for your workday. Okay, let's look at one last methodological concept as part of this first half of the session, and that's looping. And that's not a looping on a roller coaster or something, but instead, looping is possibly the most powerful concept of automation. So something where it's not fun doing it is typically a case where things are very repetitive, and that tends to be the case for something where you have to do something for maybe, okay, you've got one set of data here in this column 1, and you've got another set of data here in this column 2, and you have to do the same operation over and over again. So maybe you just want to say multiply this value here with the value here. That's a very easy case of repetition. I know you can do that easily in Excel, but we also know there are some things that are not as easy, and they have the same issue that you have to do something over and over again over the entire data, and somehow you can't automate it. Sooner or later, it comes up in our work days. So we've all been there again, including myself. Don't be afraid. It's just the Excel technology leads to this kind of case. The way around this in a programming language is a for loop. So the equivalent of what we had here in a for loop is for, and then I've got a placeholder here. You can name this anything. You can also have it something that's a bit more intuitive than just what I'm using here as I. So maybe you can say for number in range, blah, blah, blah. So for I in range, and then this range is a very handy function. Range creates an entire sequence of numbers. And I can tell it, you can start at a certain value. Sorry, there's a bit of background noise. If we can all go on mute, please. You can start at a certain value and stop at another value. And to make it a bit more intuitive, because a lot of people, especially in the beginning, struggle with we count starting at 0. Actually, this range goes from 0 to 5 inclusive, so the 6 is not included. It sounds a bit bizarre, but it's going to make your life a bit easier in the beginning, strangely. So now I is going to take every single value here from 0, 1, 2, 3, 4, 5. And I can say select the column of the value that I is currently having inside column 1, select that row, and we know how to select a row. We did that before in the code, so it's going to be the same here. And multiply it with what we have in column 2, also at the ith location. Right? This is a very, very simple example for something incredibly powerful. In fact, the for loop is so powerful that what happens in the beginning is, especially this combination of for and range, you will find it solves everything. And that's by definition, this is almost Turing complete in itself. It can solve almost everything and automate everything. So you will literally use this for everything once you fully grasp what that can all do. It can do your entire workday, just this one thing here, right? And you will use it so much, in fact, that after you progress to a certain level, you'll try and find more efficient ways of doing it. But this is always the kind of default fallback, right? You can solve pretty much everything with this, which is pretty cool. Okay. What we're going to work up to now are 3 situations that we're going to show when Python is a lot better to use than other technologies like Excel or something else. And then a 4th one we'll just briefly talk about here. To get there, let's talk about 2 small things here. One is we can define a series, right? So inside this Pandas library and this PD shorter, I have here as a shortcut, I've built that myself because I said import Pandas and then SPD. That means every time I write PD, I don't have to write Pandas anymore. This just makes it shorter. So new data is a pd.series. What is a pd.series? It's just an empty data series, right? So this is the same data series that we've grown used to before, and I'm assigning it again to a variable here. Now, because this is empty, I want to show you, you can also add some new data here. It's much easier if the new data happens also to be a Pandas series. So if I have a Pandas series that's just having the value of 0 here, right? I can also append new data very easily to this new data. So let's do that. And that's just a trick for you if you want to fill a custom built Pandas series. Maybe this data comes somewhere from your loop or something. It's a situation that sometimes arises, so it's handy to know. Now let's do a very basic loop. So first of all, let's just loop through the data that's in column 1. Right, so remind you, we've added 1 to it, so it has remembered that, luckily. And now I is going to take every single value in that column 1 inside data. And what we're going to do is we just print it here. We can also do some changes to it and then return it, or we can use it to change other things. So this is incredibly flexible. But now let's just print it out. And indeed, we have here. So that was so fast we couldn't even see, but it was in sequence. It was first doing 2, then it goes to the next value of I, and it takes 3, and so forth. Here we're doing some minor change. So in this case, what we're doing is we take the value that I currently has, we multiply it by 10, and then we do the same append to the series that we had before, this new data. So currently it just holds the value 0. Now we want to add every value in column 1 multiplied by 10. This is a very simplistic example. Obviously, there are much more complex cases which are more likely to occur. So let's see. But even the complex cases, they tend to follow the same kind of logic here. So now we have added that to our new data frame. And indeed, so the 0 is still there because we just appended. You can also just overwrite the existing data frame by re-executing this if you wanted to get rid of the 0. In this case, we're happy with it actually. And then we have every value that was in column 1 times 10 coming down here, right? So this, again, very powerful. Combination with this append function allows you to get the data out of that loop. Alternatively, as said, you can also use the return function. Once you use return, the for loop tends to collapse. So if you want to continue in the loop, this append is a powerful combination with that structure here. Okay, then also the range that we saw before, let's see that in code. So here we're now using the range going from 0 to 5. And remind you, 5 is not included, which is easier because we start counting at 0. So let's print that quickly. And indeed, we've got 0, 1, 2, 3, 4, and the 5 is not here. Again, the help function is very useful. And then we can actually see, okay, this range function has a lot more flexibility also than we initially thought. And what's crucial in that is it has this step. So you can call it in two different ways. One is you can say, just give me one value, and then it just gives you from 0 to the stop value exclusive. Or you can call it with two values, and then you can have a different starting value than 0. And optionally, there's even a third parameter, which is the step. So if we set the step for 2, it's just gonna jump by 2 in between every one of these points. The step could also be negative. So again, this makes the range function much more powerful. And typically there's a lot of flexibility in using the function parameters, same as in Excel. So that was some examples on how automation is really powerful here. So there should no more be these cases where you just go from Excel cell to Excel cell and you do it 100 times. No, here, this is just a few lines of code typically. The second example, and that's typically, that can create some very extreme situations, is when a file might be even too big to work in Excel. And there's one case which is a bit more mild, where it just says, essentially, it gives an error message. So let's create that actually. This is a very big range. So that goes from 0 to 10,000. And we've just saved that to a CSV file. Right? So I've saved that. And the first input here just says, this is the name. So I'm putting a .csv here also. And we can see it here inside the folder is the very big file .csv. This is what we just saved. And then I'm also giving it a header. This is absolutely optional. The important thing is this is a pretty big file for Excel because it has 10 million rows. So if we open that now, and there might be a delay because Excel doesn't like such files. Here we go. There's an alert, and mind you, that alert took 2 or 3 seconds to pop up, which is already not nice. And we all know these situations where we have to wait for maybe 2 minutes in extreme cases for an Excel file to even open. And now it even says, oh, I gave up. The file could not be loaded completely. So what happens if I want to do some custom operation or just view values that are beyond where this file ends? That's a very, very tricky case now. Two advantages in Python. Of course, the first advantage is it works. So I can read the file and it will not be cut off. Unless it's a really, really big file. In that case, we would need big data technology, which Python can also do. But we see here, even this file, that was 157 megabyte big, and it loaded so quickly. I can select the values very fast. So I'm selecting the value of 5 million now, and you can see it's going to be the same speed like the 10th value. Boom, there you are. That was significantly less than 1 second. So just selecting this value, which is very likely to be cut off in the Excel file because it was not fully loaded, is already a lot faster than even opening the file in Excel. Right? If we want to go there, it's going to be another delay in Excel possibly. So sizable data, again, big advantage. There are some files where Excel even crashes your computer completely. You all know that case where a file is so big in Excel, it just has a memory overspill and then the whole thing crashes. And if that happens at 10 p.m., like good luck. It's likely you lost some work that was not saved and it's going to be time for a night shift. The third situation where Python really shines as compared to Excel is, of course, things that are not possible in Excel at all. And that's absolutely fine. Excel is a great tool for many things, but then Python is essentially a more flexible tool. So one example, and I'm going to pick the just building an AI model because that's the focus of the organization in this quarter, in this year, sorry. One example is just building an AI model. If you remember our AI course, and let me just quickly bring that up again. We had that here in the very beginning. This is also a great follow-up, by the way. If you're interested in learning more about AI, we've got this YouTube-based course. It's a lot faster than learning a university course. We don't do any crazy math. We focus on the tools that you need in reality. So give it a go. We also send regular emails with the link and also the link to drawing new tests on the AI test to you. So this random forest classifier, you'll be able to fully understand it and build your own when you take that short YouTube course that we're providing. But let's just fit it to some data. So we just imported, and essentially I just need this one line of code to import a absolute cutting edge model that's the best setting that you can get for creating an AI. The second import here is just to create some artificial data, which is very handy if you want to do UAT testing, of course. So let's create some data first. And in this case, we might assume maybe this X variable here is our regressor matrix, and maybe that holds information that is important for predicting the weather. So maybe the first row is the wind direction, and the second row is telling us about the ozone values today, and then Y is just telling us what was the weather, was it sunny or not. So if we wanted to build an AI model here, you see 2 lines of code, done, right? This is how easy it is to create AI here. And that is a really, really complex AI actually that we have just built. And you have also seen how fast it was doing that for 1,000 rows of data. It took maybe a millisecond. So very powerful because we can utilize the open source work, because it is pre-built, because it is a supported technology in this framework, and that's different from other things. Now, if we want to predict something, of course, we can do that. So let's say the wind direction is 0, the ozone reading today is 10. Then we're assuming, okay, we predict tomorrow is going to be a sunny day. And maybe if the ozone reading is not so good, then we predict, tomorrow is going to be rainy. Such a pity. There's one last situation. Sorry, there's some feedback. If we could all go on mute, please. There's one last situation where Python is really powerful. And that, of course, is in sharing your work to the customers. We've talked a little bit about that before. Essentially, how it works is you can do 2 things. You can build an API. An API is an application programming interface. What it really means is your algorithm, your work, sits on the internet. That can be completely public, or it can be locked down in a sense that only people inside the company can access it. And it can be accessed by code from other people, or also by humans. So you can also put a UI on it, and then your API becomes a full-scale website as well. Or you could even put it as part of an app. So this sharing here is much more scalable, and it really can go into the hands of actual customers. Whereas with an Excel spreadsheet, I always had that feeling that when I had my Excel spreadsheets, I always had that feeling that it's hard to make it spread beyond the mailbox of a CEO person or some other internal stakeholder, right? And as you progress with that code, that is very different. You can actually work much deeper with the other departments, and you can give your output of the work directly into the customer's hands. Okay, that concludes the first part of our course, we're going to go now to the second part, which will be more focused on building the face detector. So let's see it one more time. And the cool thing is, all the things that we have just learned in the first part are really, really important actually for that second part. So what we're going to have is we will have an AI, and again, it's going to be very easy because it's pre-built, it's open source. And the AI will give us the locations of these points on the image. We will also realize the image itself is a sort of a Pandas data frame, or very similar at least. And then all that is left to do is work with the image as a data source and work with the data points and put it all together.